Welcome back to the Depth Dive. Today, we're going to get pretty specific. We're looking at a single component, the NTI E-RTDS-A221.
The all-purpose 100 ohm RTD sensor.
Exactly.
Yeah.
And our mission here is to figure out why a sensor like this, with what seems like a pretty moderate temperature range, is so essential.
Well, the whole story is right there in the name.
Huh.
It's an RTD, a resistance temperature detector.
Right.
And the key part is that 100 ohm PT385 curve. That's not just jargon. It's, the sensor's core principle. It's a platinum element that's calibrated for incredible stability.
So you're not buying it for its massive range, you're buying it for confidence.
That's it. It's about trading range for resolution, for really high confidence in the data.
Which explains the moderate range. We're talking, what, negative 67 degrees alpha up to 221 degrees alpha?
Or negative 55 degrees, 205 degrees, yeah.
But here's the payoff, right? The accuracy is just razor thin. It's a 0.27 degrees RFI. So for someone managing a lab or a data center, what does that fraction of a degree actually mean?
It means everything. I mean, it's the difference between passing and failing an audit. In HVAC systems, in pharmaceutical storage, that HEA 0.15 degrees C accuracy is often non-negotiable. It's a compliance thing.
And to get that, I assume the build quality has to be, well, pretty serious.
It does. Let's talk about the physical features because they matter a lot here.
Right, I'm looking at it. It's rugged, it's waterproof.
And encased in 304 stainless steel, that's not trivial. Plus the fitting, the brass fitting, with the 12 NPT male thread.
So this is designed to be installed and then just left there.
Permanently. It's a fixture. And the dimensions are all about the application. We've got a 9-inch probe.
229 millimeters.
Connected by a pretty short 18-inch 2-wire lead. And that 9-inch length, it isn't random.
Okay.
It's engineered specifically to reach the center line in a standard HVAC duct or a deep immersion well. You put it in the one perfect spot and you trust it.
Got it. So the physical design makes sense. But let's talk integration. I mean, this is a passive component, right? It needs help to talk to a system.
It does. It requires a transmitter, something like an NTI E-RTD-T140 or one of the other models.
And a control unit.
And a control unit, yeah. The sensor just measures the resistance. The transmitter is what turns that into a signal the system can actually understand.
Okay, but this is where I get a little confused. I saw that one of the compatible transmitters, the ERTDS-1562, can handle temperatures up to, like, 1,562 degrees Fahrenheit?
Yeah, it has a massive range.
So, hang on. If the electronics can handle these huge extremes, why are we paying $130 for a probe that maxes out at just 221 degrees Fahrenheit?
That is the perfect question. It's the trade-off we mentioned at the start.
Okay.
You are paying for verified, rock-solid accuracy within that very specific, very critical HVAC range.
I see.
A wider range sensor, by its very nature, it sacrifices some of that ultra precision. The cost here is for the reliability and for the certifications. It has CE approval, it's TAA compliant.
Yeah.
That's a guarantee.
Okay, let's wrap this up then. The big takeaway is that the NTI E-RTDS-A221, it isn't an extreme weather sensor.
Not at all.
It's designed for perfection within a very common but very critical environment. It's for places where that tiny fraction of a degree is the only thing that matters.
Exactly. Which brings us to the final thought for you to chew on. NTI sells dozens of different pipe and immersion sensors.
Right.
So the question is, what specific regulatory body or what unique facility requirement dictates this exact combination? The 9-inch probe length and that strict 0.27 degrees solid accuracy. It's a fascinating look at how compliance really drives engineering.